Welcome to the Clock Tips Podcast. I'm your host, Dr. Melissa Richardson. Thanks for joining us. After I did the study on just looking at how does the fragmented day-night cycle or the FDN cycle causes, potential changes to circadian rhythms, which it did, and mood, I thought the reason I made this whole paradigm in the first place is because I was really thinking about those moms and dads who are awake at different times of the night and maybe napping in the day, just trying to take care of their baby. And I decided to do a study looking at how being born and being raised in such an environment where there's light and dark at different times of the 24-hour cycle might affect development and behavior. So this next study is called The Fragmented Day-Night Cycle Induces Reduced Light Avoidance, Excessive Weight Gain During Early Development, and Binge-like Eating During Adulthood in Mice. What I did here was just to design an experiment where I had mice in normal environment and mice in this fragmented day-night cycle. And the moms, when they were about a week pregnant, and for mice, they take 3 weeks before they give birth. And about a third of the way in, I put some of the mice that were in the normal environment over into this fragmented day-night cycle. So I exposed the mom to the messed up cycle before they gave birth. And then I observed how the moms took care of their pups after they were born and just how the pups were developing. So starting with how the moms took care of their pups, I didn't see a difference between the mice that were taking care of pups in the normal environment versus the fragmented day-night cycle. It seems like the moms, they made it work, basically. But then when I start to look at the pups now, I saw some really interesting things. So I said, what are some measurements that I can take with pups, mouse pups? So I took their weight every day. I measured that. I measured whether the moms were taking care of them. So I counted how many pups were in the litter and, if they were all surviving well in this environment, things like that. But the thing that was most shocking to me that I was just doing baseline measurements like taking the weight around day 6 or so, closer to a week. I really noticed that the mice looked really different. And I went and checked the birth date because I came in every day to see when were they born. So I know exactly when the mice were born. But I noticed they were so big. I said, wait a second. I thought these mice were born a week ago. Why do they look like they were born, longer than that ago? And I said, okay, let's get another litter and another litter. So I looked at multiple litters of mice that were born into this fragmented day-night cycle, and they all gained weight much faster than the mice in the normal day-night cycle. Now, this is not unique to mice as far as weight regulation during development. Because there is a study in humans where babies who were in the NICU needed to have a good day-night cycle regulation in order to actually put on weight so that they can, be mature enough to go home. So having a good day-night cycle environment is important for proper weight regulation in humans as well. Now, in addition to that, something, I want to look at is that these mice are developing under this disruptive environment. So are they perceiving the environment differently than their counterparts who are in the normal environment? I did this study where it's called a light avoidance study, and pretty much the mice are in the dark and they're little babies, but what they will do is if you shine light and they can sense the light, they can just turn away from it, meaning that they're sensitive to it. And what I found is that only about 50% of the mice that were in the disruptive environment turned away from the light compared to closer to 80 to 90% of the regular mice, which means that these mice that are developing might not be noticing the environment as much as the mice in the normal environment were noticing it. So the information going into the brain does not seem to be the same. And maybe that is what's helping with this extra weight gain that I saw. These mice were exposed during the first 2 weeks of development to this disruptive environment. And the part that I want to mention next is what happened when they grew up. After just being 2 weeks in this disruptive environment, they gained weight really fast, had poor light avoidance. I put them back into like the normal environment, and by 1 month or 4 weeks old, they were looking pretty similar to the mice that were grown up in the normal environment, which means that this effect wasn't a long-term thing. It could be reversed. So just fixing the environment, changing it to something better, helped a lot. Now, what I did when these mice were adults, so about 2 months old, is that I challenged their eating abilities with a paradigm I call the binge eating paradigm. And what it is that I took away their food for 1 day, kind of like a fast. People do the same thing. And then I returned the food to them 24 hours later and look to see how much food do they eat in 1 hour compared to what they would normally eat in the entire day. And what I found is that the mice that are raised normally, so in the normal day-night cycle, they didn't show any, they had a baseline. So that was the baseline. Whatever they did was going to be the control, right? So I saw what they did, but then I put those same mice that were raised normally into the fragmented day-night cycle for 2 weeks, and we know that causes mood issues and things like that. But even then, I didn't see any type of, overeating in that 1 hour when normal mice were put into this disruptive fragmented cycle environment. So they were fine, okay? Now, going back to those mice that were actually raised for 2 weeks in that fragmented cycle, in adulthood, when they were still now back into the normal environment, they didn't binge eat. But when I put those fragmented raised mice into the fragmented cycle again, when they're adults, that's when they showed a phenotype or a behavior of binge eating in both males and females, by the way. And so what this means is that early exposure during development to this disruptive environment was enough for their brain to remember and somehow might have just, and this is to be further studied, of course, but my hypothesis is that how their brain developed in the fragmented environment affected them in a way that if they're reintroduced into this disruptive environment, they have these kind of overeating behaviors again, or they have overeating behaviors like higher food consumption, which is what we saw here. So how you grow up matters for how you are as an adult, which is definitely something we've seen in humans in different ways as well. But I really want to emphasize here, the only thing that we changed was the timing of when the light and dark happened. Again, we have 2 hours of dark and 4 hours of light alternating throughout the day. And that was enough to cause all of these issues. So the take-home message here is the timing of lighting really matters. And it matters in more ways than just, my circadian rhythms are off. It can affect how much we eat and how it affects how our body uses that energy for metabolism and breaking down our food. And it can lead to weight gain. Thanks for joining us today. Please visit our website at clocktips.com for more information about this podcast, how to join our ongoing research study, and more resources to help you improve your time intuition, sleep, and productivity. If you found this information helpful or interesting, don't keep it to yourself. Share it with others and join the discussion on our social media platforms under the handle @myclocktips. Until next time, take care of yourself.